Hi everyone, welcome back to my channel. So this dipole moment topic is a very important chemistry topic, and these questions related to this are often asked in the competitive exams like JEE and NEET, any exams like this. So I hope this concept of this dipole moment it may help you. So I am sharing that's why this video with you. So let's begin with this topic. So you know that dipole moment is a vector quantity, so it is having both magnitude and direction. Then the product of this charge and distance between these two dipole is also called as dipole moment. So the formula is mu is equal to q into d. So d is nothing but here distance, and q is nothing but charge, and its unit is d. So here two types will be there. When you are going to process the dipole moment of the any given compound, there will be 2 points you should remember. That is what one is polar and non-polar dipole moment. So for that some of the rules will be there. I am going to predicting here. So what are those rules? When you can say the polar dipole moment, this is the polar dipole moment. So let's start one by one. The rule: when two dissimilar atom combines to form polar, means the atoms should be not similar. Okay, then there will be what happens, there will be difference in their electronegativity. Here general example, that is A B. So here what happens, B is more electronegative element than this A1. So this is what difference in the electronegativity. So what happens, the bonding electrons are shifted towards the more electronegative atom. So here B is more electronegative atom, that's why it abstracts the bond pair of electrons from the A. So next you should see the rules. Atom gets partial delta plus charge while other gets partial negative charge. So here this more electronegative element which gets the partial negative charge, and this atom gets partial positive charge. So thereby that's why we are going to call as this one is a permanent dipole moment. So that's why its value is mu is not equal to 0. It may be something, whatever it may be, but here its polar dipole moment value will be not equal to 0. I mean it may be some of the values. So example, you can say dissimilar atoms, that is hydrogen chloride, hydrogen bromide, hydrogen iodide, hydrogen fluoride, like this. So these examples, so their polar will be polar in nature. That's why their dipole moment value will be not equal to 0. Next, rules for the non-polar dipole. So this is what just opposite to the polar dipole. So what happens here, the two similar atoms must be combined. So example, I can say that S2 O2 N2 like this, because these atoms are similar. So that's why their dipole moment value will be 0. So because here there is no any difference in the electronegativity, because these atoms are similar, and hence there is no bond pairs also. Because bond pairs are not equally distributed, hence there will be no charge, hence there will be no dipole moment, hence this value will be purely mu is equal to 0 value. So here we can take some notes from these above points. So you know that central atom should not have any lone pairs of electrons, then only you can tell the non-polar. This is the non-polar atom. Okay, next second one is all atom attached to the central atom must be same. Like example BF3 I am going to take here. Here BF3. What happens? These all atoms which is attached to the central atom is here boron. So must be same like this. And here it should not have any lone pair of electrons. So like this we can give the examples. So later I solve the one by one problems by acquiring these rules. Some more general rules on dipole moment will be there. So as the dipole moment value increases, the electronegativity also increases. I mean that is, dipole moment is always directly proportional to electronegativity. And second one here, here you see the condition of this benzene ring, here A and A, because this is what the same nature of these atoms. So what happens in the same nature and in a different nature, there will be here ortho isomer will be greater than meta isomer will be greater than para isomer. So in case of opposite different nature, what happens here, ortho is less than meta is less than para. And one more, this when the compounds are given in the problems, cis isomer or trans isomer, there will be cis isomer must be greater than the trans isomer. So this fourth rule from the general rules, this is also very important. So here the angle is inversely proportional to dipole moment. I mean the increase in the value of the angle, the decrease in the dipole moment. So that's why dipole moment increases, the angle will be decreases, that is vice versa. This concept is also explained on the hybridization topic. So here the sp hybridization I am going to take here. So sp hybridization will be the linear structure, and examples are BF2 and CO2. So what happens, there will be, you see here there is no lone pair of electrons on the center atom. So that's why its lone pair is 0, hence the dipole moment value will be 0. Come to this sp2 hybridization. Here if the lone pair is 0, that is called as the structure is called trigonal planar, and here bf3, bcl3, so3, these are the example for this sp2 structures, and here there is no any lone pair, so that's why the lone pair is 0, that's why this dipole moment value will be 0. Come to the sp2 here, one lone pair bent structure SO2, SN2, these are examples. So there will be, because some lone pairs will be present on the sulfur atoms, so that's why its dipole moment is not equal to 0. Like this sp3 here, 0 lone pair, tetrahedral example for methane and silane, so there will be mu is equal to 0 because there is no lone pairs. So when in sp3 only, if one lone pair is present, that is called pyramidal. Example is ns3. You know that ns3 is it is polar in nature, so its dipole moment is not equal to 0. And again come to the sp3 d, sum of this lone pair is 0, trigonal bipyramidal. Example pcl5, its dipole moment value will be equal to 0. So based on all this I have given the information. So please pause this video and get the screenshot, then only we can understand further, because this video is a short length video. Here there will be set of problems will be there, so you should find out the in the decreasing order of the dipole moment values. So you know that one of the rules says that the mu value goes on increases, electronegativity difference will be increases, and you know that dipole moment always directly proportional to electronegativity. So here the higher the electronegativity, hence its dipole moment will be greater than this HCl. HCl is greater than HBr, HBr is greater than HI. So similar here, fluorine, bromine, iodine will be there, so that's why its order will be like this. And here come to here, so here so quite different will be there. Here one Cl atom is there, here 2 Cl atom is there, and here 3 Cl and 4 Cl. You know that when the withdrawing group goes on increases, Cl is a withdrawing group, halogens are also best withdrawing group I can say. So as the number of Cl atom goes on increases, the dipole moment value decreases, hence the order will be like this. So these examples for the Ab2 type molecules. So here this is carbon dioxide and this is sulfur dioxide, and this is a famous water. So here what happens, this is a linear structure because and here this is a sp and sp hybridization. So here what happens, the electronegativity difference between oxygen and carbon, so oxygen is a more electronegativity, that's why I make it as a like this arrow mark. And here because this oxygen electronegative atom which are going to pulling the electrons towards itself, so here what happens, the charge will be in the opposite direction will be opposite in direction, that's why it will cancel out, that's why its dipole moment value will be 0. And here unlike this CO2, this SO2 is not linear because of this presence of this lone pair of electrons. So its SO2 molecule is like a water only because it is bent and this is also bent. So here what happens, here oxygen is more electronegative than sulfur, and here the direction, even though it may it comes to the opposite direction, but even though its dipole moment will be not equal to 0. And here water, here the electronegativity towards oxygen only, so all are in the same direction only, so that's why it does not cancel out, and hence its dipole moment value will be something will be there, but not equal to 0. So to solve this type of problems also there will be one rule I have mentioned that, so central atom should not have any lone pair of electrons. This is one condition, then only we can say that it is a non-polar, and also all atom attached to the center atom must be same. So here the all atoms attached to the same metals will be there, and here there is no lone pair of electron, hence its dipole moment value will be 0. Come to this one CCl4, and here also you make it like this because this all are in the opposite direction, and here also because electronegativity atom is chlorine which attracts the bond pairs of electrons, so because they will be cancel out each other, that's why its dipole moment will be 0. And this is what CS3Cl, here this dipole moment is not equal to 0 because what happens, all are in the same direction only, because this direction towards the Cl and hydrogen and carbon is the more electronegative, that's why this will be the direction will be same like this, that's why its dipole moment value will not be equal to 0, something will be there but it is not equal to 0. Come to here SO3, here electronegativity is oxygen and less than this sulfur. What happens, they are in the opposite direction, hence the dipole moment value will be 0. And here also same, the more towards the oxygen, and here this will be cancel out, so that's why dipole moment value will be 0. And here also same, the fluorine will be having the more electronegative, so and also this lone pair will be there, so towards the lone pair, so they are opposite in direction, that's why its dipole moment value will be 0. So I have taken two examples, that is ClF3 and PCl3. Their dipole moment is not equal to 0. So because it is a, you know that ClF3 is a T-shaped, I have mentioned in the hybridization concept, so that's why its dipole moment is not equal to 0. So here what happened, this is a T-shaped with asymmetric charge distribution around the central atom, so that's why this comes to the polar. And here also same, this is also asymmetric due to the lone pair of electron, which causes the dipoles to not cancel out each other, so that's why this is also polar compound. As I mentioned in the hybridization, this PCl5 is an sp3, I mean trigonal bipyramidal. So this dipole moment value will be equal to 0 because of this difference in the electronegativity. So they gets cancel each out. So that's why dipole moment value will be 0. So here in this case, let's find the polar order. So here in CH4, I told that this dipole moment value will be 0 because the bond dipoles cancel each other due to the more electronegativity difference of the carbon and hydrogen. And comes to this NF3 here, the bond dipole of the lone pairs and resultant dipole of the 3 NF bonds are in the opposite direction. So and in come to the ammonia, so these are in the same direction, always in the same direction with the lone pair of electrons. So that's why the order will be like this. And here in the case of water, what happens, the dipole moment of water is the greater than all these, because here the oxygen is a more electronegative atom is there, because more electronegative atom than this nitrogen. So that's why this comes to the more dipole in nature. Let's solve this problem. We should arrange the in the decreasing order of the dipole moment. So here you know that this para dichlorobenzene, here what happens, the more electronegativity is chlorine than rather than carbon atoms. So that's why the direction will be like this, they are in the opposite direction. So that's why this is cancel out. So this comes to the least priority. So that I am going to write here. And first you take the examples of this problem, second one and third one. Here this is orthochloro and this is metachloro. What happens here, the bond angle will be around 60 degree will be there, and this is 120 degree. So as I told that the angle is inversely proportional to dipole moment. So that's why this ortho will be the comes to the ortho first, and second will be the meta position, and this one is the fourth one is the least, because this fourth one what happens, the all in the same direction, because hydrogen is less electronegative than carbon atoms. So it will be like this. So let's find here the dipole moment in this is orthonitrophenol and this is paranitrophenol. So once again here will be the bond angle will be around 60 degree and this bond angle will be 180 degree. As I told that the angles which is inversely proportional to dipole moment, so that's why the order will be like this. So here let's find the dipole moment. So as I told that the in the nature is the same, that is Cl and this Cl is the nature will be same, then the ortho will be the predominate over these molecules. So in this case the nature will be different, because this CS3 and this NO2 will be the different moiety. So what happens here, the para will be the leading. So that's why I am going to write this is order. So because these will be the in the same nature and this will be in the opposite nature, I will different nature. So in this case here, this is a para-dichlorobenzene and this is hydroquinone. So here what happens, this para-dichlorobenzene has a 2 Cl, here Cl and this Cl. So it should be having the more electronegative than the carbon atom, hence which pulls the electron towards them. So hence this dipole moment value will be 0. Whereas in this hydroquinone, what happens here, this is a sp3 hybrid orbital oxygen atom, so which has 2 lone pairs of electrons which which are responsible for non-zero dipole moment. So in this case, this is a cis isomer and this is a trans isomer. You know that cis isomer is greater than trans isomer, because here the electronegativity difference will be in the carbon and chlorine. Here the direction will be in the same side, but here direction is in the opposite side. That's why it cancel out. So its a dipole moment value will equal to 0 and here not equal to 0. Come to this category. So you know that this is everything is orthoisomer, and here this is NO2 group is nothing but minus I effect and minus M effect, and here it is a minus I and a plus M effect. So this is a purely plus I effect. So that's why this orthonitrophenol will be greater than these compounds. So this is a dipole moment value will be like this order. In this case of this dipole moment, this chemical formula is PF2Cl3 and this is a PF3Cl2. So we know that the more electronegative element occupies always in the axial position. So this is what sp3d. So in PF2Cl3 what happens, the both fluorine occupies opposite axial forces. That's why they will be opposite in direction. That's why it cancel out. Its dipole moment value will be equal to 0. We will come to here in PCl2F3, both axial positions are occupied by fluorine atoms and one planar is occupied by fluorine and remaining will be the chlorine atoms. So here these two Cl atoms also lies in the same planar. So due to this is unsymmetric and unsymmetry fact, and here Cl and F both have different individual dipole moment. That's why this is not equal to 0. We have discussed many problems on the dipole moment, so which are very useful in your competitive exams. So if you like this video, please subscribe it, and please share it also with your friends. Thank you.